Back, Mrs. Thompson, with your lesson for today, box plots, which are also known as box and whisker plots, and I think you'll find out why as we move into the lesson. Your essential question that you should be able to answer at the end of the lesson today is how can you use a box plot and measures of spread, remember we talked about range and interquartile range before, to describe a data set. Let's get started. A box plot is a display that shows how the values in a data set are distributed or spread out. To make a box plot, find 5 values for the data set. Now this might look like a little bit confusing, but I really think you already know this information. The least value, that should be easy. If I order them from least to greatest, right? The least value is the furthest to the left. The greatest value is furthest to the right, so that should be easy. These two you should be able to visually see. The median, we've already talked about how to find the median. Remember, if I have a list of data that's written least to greatest, I can cross off pairs, least and greatest, until I get to that middle value and we find the median. So we've worked with median. And lower quartile and upper quartile, you actually computed when you did your measure of spread lesson. Remember, that's finding the median of the lower half. So if this is my lower half of data, I can find the median of that data, which is 2.5. That would be my lower quartile. The upper quartile is just finding the median of the upper half. So if I cancel these out, between 7 and 7 is just 7. That would be our upper quartile. So you've already found how to figure out these 5 values that you need, and those are the only 5 values you need for a box plot. So let's get started and try to create one together. The grades on a science test are shown in the table. Make a box plot for the data. The first thing we have to do is order the data and find the 5 needed values. So we're going to order them least to greatest. We've been doing this a lot, so remember we cross off if we can to make sure we get all the values. 76, 78, 80. Here's an 81. I wish you could all help me find these because I think you'd be able to find them faster. I know you'd be shouting them out. Oops, that should be an 87. Oh no, and I just deleted everything. So let's start again. We had 63, 75, 76, 78, 80, 81, 87, that's where I made that mistake last time, 89, I have 2 91s, I have a 95, and a 100. Now remember, before I continue with my data, I always check to make sure I have all my data points. So I have 2, 4, 6, 8, 10, 12. I should have 12 data points written here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and I do. So we have to find 5 data points. Remember, we have the least number, that's easy, and the greatest number. So those are 2 values that we need, the least and greatest. We also need the median. So let's find our median quickly by crossing off least and greatest, least and greatest. I'm doing this very lightly so I don't have to rewrite my numbers. Least and greatest, and I have 2 in the center, so my median is going to be right here. How do I find median if I have 2 values? Do you remember that you add them together and you divide that number by 2? And we come up with 84. So 84 is our median. Now what that did is it split the data into two halves, right? Here is my lower half, and here is my upper half. So 81 is considered part of the lower half, and 87 is considered part of the upper half. So now I have to find my median of the lower half. That's going to be my lower quartile. So I cross off least greatest, and the median between 76 and 78 is 77. That's my lower quartile. We're going to do the same with the upper half by crossing off least greatest. Ooh, in between 91 and 91, that's easy. It's just 91. So those are our 5 data points that we need for our box plot. Now a box plot starts with a number line that spans all of my data. Now I can't make my number line using 63, 77, 84 because then my box plot's not going to be realistic. But I know I have to cover numbers from 63 to 100. And remember, number lines don't have to have zeros. So let's start. I'm going to go by 5s and do 60, 65, 70, 75, 80, 85, 90, 95, and 100. So now I have a perfect number line where I can plot my data points. Box plots are plotted slightly above the number line. So I'm going to put a point at each of these numbers slightly above the number line. So 63, I'm going to estimate is going to be right about here. There's my point. 77 is going to be right about here. There's my point. 84, do you see how they're slightly above the number line? 91 and 100. So all I did was took my values and plotted them slightly above the number line. Now I'm ready to make my box. I'm going to take the 3 center value points. This is my lower quartile, my upper quartile, and my median. And I'm going to draw a box around those two with a line down the center of the median. So there's my box, and if you remember earlier I said sometimes it's called box and whisker because the last step is to draw your whiskers to your extremes, your least and your greatest value. Now this is very helpful because remember these are quartiles, so this amount of data is 25% of the data. This part is 25% of the data. This part is 25% of the data. And this part is 25% of the data. Now in a box plot, I can't determine what the mode would be because I have no idea just looking at this information. But I can see the measures of spread. And remember, we had 2 measures of spread that we talked about. The first one is the range. Remember, range is just the greatest minus the least. So I'm going to take 100 and subtract 63, and I end up getting 37. So my range is 37%, right, or 37 points. But we can also determine the interquartile range, or the IQR. Remember, IQR was the difference between the upper quartile and the lower quartile. It's really easy to find this in a box plot because I already have my upper quartile listed right here and my lower quartile listed right here. So the interquartile range is going to be the distance from one edge of my box to the other edge of my box. So I'm going to take that 91 and I'm going to subtract this 77. So it's easy to find interquartile range when we have a box because it's one edge to the other. And there you have it. You've been able to create a box plot. Now let's compare some box plots to determine information that we're asked about. Here are 2 box plots that show the distribution of number of rides given per day by two taxi drivers. The blue taxi driver is Ace Taxi Service and Safeway Cab Company is in red. Which driver has a greater median? Well, that's pretty easy to tell because remember, our median is that line that's in the center of the box. So here, Safeway has a median of 25. Ace Taxi looks like has a median of, it looks like 37. So we've got Ace Taxi would be our greater median. Which driver has a greater IQR? Remember, that's from one edge of the box to the other. So 40 minus 20, that would be 20 for Ace, and 40 minus 20 is 20 for Safeway. So they're exactly the same. And which driver is more consistent? I want you to think about the range for this one. Which one's more compacted? If they're more compacted, that means that their rides all occur within that distance. So if you see Ace Taxi Service goes all the way from 10 to 60, it's quite spread out. But Safeway Cab is very condensed. So Safeway is going to be the more consistent. Good luck in drawing box plots and comparing box plots, and let your teacher know if you have any questions. Have a great day.